Welcome back, amazing people. Today we're tackling a topic that confuses even tech enthusiasts: the difference between artificial intelligence, machine learning, and deep learning. These terms are everywhere, but they're not the same thing. In this video, we'll break them down with simple analogies and real-world examples, so you'll finally understand how they relate and why it matters. Whether you're a student, a professional, or just curious about technology, this guide is designed to make things crystal clear. Let's get started and unravel the mystery behind these buzzwords. You've probably heard AI, machine learning, and deep learning used interchangeably. It's easy to get confused because they're closely related, but each has a unique meaning and role in modern technology. Understanding their relationship is crucial for making sense of how smart devices, apps, and services work today. In this video, we'll use clear analogies and practical examples to show you exactly how these concepts fit together. By the end, you'll know how to spot the differences and see how they work as a team. Imagine AI, machine learning, and deep learning as Russian nesting dolls. The largest, outermost doll is artificial intelligence. This is the broadest concept, covering any technique that allows computers to mimic human intelligence. Inside that, you'll find machine learning, a subset of AI that focuses on letting computers learn from data. Finally, the smallest doll is deep learning, a specialized form of machine learning that uses complex neural networks. This nesting doll analogy is the key to understanding how these technologies relate. AI contains machine learning, which contains deep learning. Artificial intelligence, or AI, is the overarching science of creating machines that can simulate human thinking and behavior. The key idea is to make machines smart enough to perform tasks that usually require human intelligence. Think of AI as the entire field of study, much like biology is the study of life. Examples include a computer playing chess, a chatbot answering questions, a robot navigating a room, or Siri understanding your voice. There are many ways to achieve AI, and machine learning is just one of them. AI is all around us, often in ways we don't even notice. When you use a voice assistant, play a game against the computer, or interact with a customer service chatbot, you're experiencing AI in action. These systems are designed to mimic human intelligence, making our lives easier and more efficient. The beauty of AI is its versatility. It can be applied to countless fields, from healthcare to entertainment. Remember, AI is the big umbrella under which other technologies, like machine learning, operate. Machine learning, or ML, is a specific approach within AI. Instead of programming every rule, we let computers learn from data. The key idea is to show the computer examples and let it discover patterns on its own. For instance, instead of telling a computer, if an animal has whiskers and a tail, it's a cat, we show it thousands of cat pictures and let it figure out what makes a cat. Machine learning powers things like email spam filters, Netflix recommendations, and credit card fraud detection. Think of machine learning as teaching a child by showing them examples, rather than giving them a rule book. The computer learns by observing patterns in the data you provide. This approach is more flexible and powerful than traditional programming, especially for complex tasks where writing every rule would be impossible. ML is used in many real-world applications, from predicting the weather to recommending your next favorite movie. It's the engine that powers much of today's smart technology. Deep learning, or DL, is a specialized type of machine learning that uses artificial neural networks with many layers. These networks are inspired by the human brain, with interconnected neurons processing information through multiple layers. The term deep refers to the many layers of processing, each extracting more complex features from the data. Deep learning is especially powerful for tasks like image and speech recognition, where it can learn extremely complex patterns from massive datasets. In deep learning, the first layer might detect simple features, like edges in an image. Middle layers recognize shapes and patterns, while the final layers identify complete objects, such as faces or cars. This layered approach allows deep learning systems to handle very complex tasks that would be impossible with traditional programming or even basic machine learning. It's like having a very sophisticated student who needs lots of examples but can learn incredibly detailed and abstract concepts. Let's compare traditional programming, machine learning, and deep learning side by side. Traditional programming relies on humans to write every rule. Machine learning learns rules from data, requiring a moderate amount of labeled examples. Deep learning goes a step further, learning both features and rules from vast amounts of data with minimal human intervention. Each approach is best suited for different types of problems, from simple rule-based tasks to highly complex pattern recognition. Here's a simple analogy. AI is like the concept of transportation. Machine learning is the engine that powers modern vehicles, and deep learning is a high-performance sports car engine. Each plays a different role, but they all contribute to moving us forward. This analogy helps illustrate how these technologies build on each other, with deep learning representing the most advanced and specialized form of intelligence. Let's look at spam detection as an example. With a basic AI approach, you might use simple rules like, if an email contains the phrase free money, mark it as spam. Machine learning improves on this by learning from thousands of spam and non-spam emails to identify patterns. Deep learning takes it further, analyzing not just the content, but also sender behavior and writing style, achieving much higher accuracy. Each approach builds on the previous one, making spam detection smarter and more effective. Face recognition is another great example. Early AI systems measured distances between facial features like eyes and nose. Machine learning improved this by learning from tagged photos, identifying key features automatically. Deep learning revolutionized face recognition by learning what makes each face unique from millions of images, enabling systems to recognize faces with incredible accuracy even in challenging conditions. Self-driving cars bring all three technologies together. AI sets the overall goal of autonomous driving. Machine learning helps the car recognize traffic patterns and make decisions based on experience. Deep learning enables the car to instantly identify pedestrians, read road signs, and make complex driving decisions in real time. This combination of technologies is what makes self-driving cars possible, blending broad intelligence with specialized learning. If you're just starting out, begin with AI concepts to build a strong foundation. Then, move on to machine learning, which is the most practical entry point for beginners. Once you're comfortable, you can dive into deep learning for more advanced applications. This step-by-step approach ensures you understand the basics before tackling more complex topics, making your learning journey smoother and more effective. There are many exciting career opportunities in this field. AI engineers need a broad understanding of all three areas. Machine learning engineers specialize in ML algorithms, while deep learning engineers focus on neural networks. Each role requires a different skill set, but all are in high demand as technology continues to evolve. Choosing the right path depends on your interests and career goals. An AI engineer is like a generalist, with a broad understanding of artificial intelligence, machine learning, and deep learning. They design and build intelligent systems that can solve a wide range of problems. This role requires both technical knowledge and creativity, as AI engineers often work on cutting-edge projects that push the boundaries of what's possible. Machine learning engineers focus on developing and optimizing ML algorithms. They work with data, build models, and fine-tune systems to achieve the best results. This role is ideal for those who enjoy working with data and solving complex problems. ML engineers are in high demand across industries, from finance to healthcare to entertainment. Deep learning engineers specialize in building and training neural networks. They work on advanced projects like image recognition, natural language processing, and autonomous systems. This role requires a deep understanding of both theory and practical implementation, as well as the ability to work with large datasets and powerful computing resources. It's important to remember that deep learning is a type of machine learning, and machine learning is a way to achieve artificial intelligence. They're not competitors, they're different tools for different jobs, all working together in the same toolbox. As technology advances, the lines may blur, but understanding this relationship will help you make sense of the tech world for years to come. Artificial intelligence, or AI, is the science of making machines smart. It covers everything from simple rule-based systems to advanced learning algorithms. The goal is to create systems that can perform tasks requiring human-like intelligence, such as understanding language, recognizing images, or making decisions. AI is the foundation for all modern intelligent technology. Machine learning is a subset of AI that focuses on teaching computers to learn from data. Instead of programming every rule, we provide examples and let the system find patterns. This approach is more flexible and powerful, enabling computers to handle tasks that are too complex for traditional programming. Machine learning is the driving force behind many smart applications today. Deep learning is a specialized branch of machine learning that uses artificial neural networks with many layers. These networks are inspired by the human brain and excel at learning from massive amounts of data. Deep learning is responsible for breakthroughs in image recognition, speech processing, and autonomous systems. It's the most advanced form of machine learning available today. Traditional programming requires humans to write every rule, making it suitable for simple, rule-based tasks. Machine learning learns rules from data, handling more complex patterns. Deep learning goes even further, learning both features and rules from huge datasets with minimal human effort. Each approach has its strengths, and choosing the right one depends on the problem you're trying to solve. The amount of data required increases as you move from traditional programming to machine learning and then to deep learning. Traditional programming needs only a few rules. Machine learning requires a moderate amount of labeled data. Deep learning, on the other hand, needs vast amounts of data to train its many layers. This is why deep learning is often used in fields where large datasets are available, like image and speech recognition. Traditional programming requires a lot of human effort to write and maintain rules. Machine learning reduces this effort by letting the computer learn from data, though humans still need to label examples. Deep learning requires the least human effort for feature engineering, just feed in the data, and the system learns on its own. This shift allows us to tackle more complex problems with less manual work. Each approach shines in different scenarios. Traditional programming is best for simple, rule-based tasks. Machine learning excels at complex pattern recognition, like spam detection or movie recommendations. Deep learning is ideal for very complex problems, such as image recognition, natural language processing, and self-driving cars. Understanding these strengths helps you choose the right tool for the job. AI, machine learning, and deep learning are transforming industries worldwide. From healthcare and finance to entertainment and transportation, these technologies are making systems smarter, faster, and more efficient. As they continue to evolve, their impact will only grow, opening up new possibilities and career opportunities for those who understand how they work. Think of AI, machine learning, and deep learning as different tools in a toolbox. Each has its own strengths and is suited for specific tasks. They're not competing, they're complementary. By understanding how they fit together, you can make better decisions about which technology to use and how to approach new challenges in the tech world. We hope this guide cleared up the confusion between AI, machine learning, and deep learning. Remember, these technologies work together to power the smart systems we use every day. As technology advances, understanding their relationship will help you stay ahead in the ever-changing tech landscape. Keep learning, stay curious, and you'll be ready for whatever the future holds.